going to be presenting the story of the universe. So if you would all like to accompany me to the back of the room, we can get started. Back of the universe. It's a big old story.
Can you see how it's good for you? Yeah. It's nice, eh? Good, good, good.
Okay, we can all just stand around or have a seat if you would prefer.
Did you want to sit?
Just like our ancestors from the past, we wonder where things come from. Where does rain come from? Where does grass come from? Where does the sun and the stars come from? This wonder is what drives us to explore our cosmos. I would like to invite everyone to close their eyes for a minute and just think about everything that you have seen today. Have you seen cars and trees, grass, people, mobile phones? Now I'd like you to imagine that one by one that these things disappear. In the beginning, there was nothing. There were no cars. There were no trees. There were no cities. There were no streets. There were no oceans and no rivers. There was just a vast nothingness. And in this nothingness, it was so dark that on our darkest night, it would seem like a bright light compared to this darkness. You may open your eyes if you choose. Suddenly, in an instant of great energy, there was light. That's awkward. This light was greater than anything that we could imagine. And within this light, there was a vast cloud. Cloud containing all our stars, all our planets, everything that we know today. Within this cloud, all the elements that we know today were there. Over the next 5 billion years, these particles continued to move through this vast nothingness. And some particles joined where others repelled each other. This was due to a law of the universe. In this container I have some water and I'm going to drop some paper into it, which will show how the particles either attract or repel each other. As you can see, some of the particles are moving away where others are staying together. This is the force at work. When we look at the sky, we see millions of stars. But every star we see is in our own galaxy, the Milky Way. Even the stars of our own galaxy are so far apart that the light of some of the stars takes millions of years to reach us. Do you know how fast light travels? Anybody? No? It does talk about miles, but converted it's 160 kilometers an hour. Yeah? 320? No. Light travels 299,337 kilometers a second.
Whoa.
Do you know how fast that is? That. That is how fast light travels. It takes like 1 second to travel 7 times around planet Earth. If we were to drive in a car at 100 miles an hour or 160 kilometers an hour, it would take us more than 10 days to travel around the Earth 7 times. 50 million years ago, in another cosmic instance, our beautiful sun was born. It was being pulled together, all the particles were being pulled together. And as the particles came together, smaller clumps formed around the sun, which are the planets of our solar system. There are so many stars in the universe that scientists have calculated that the distance between Auckland and Wellington and the surrounding states is approximately 651 kilometers. If you filled that with grains of sand up to 200 meters high, that is how many stars there are in the solar system. Roughly about all the sand on planet Earth. And one of those grains of sand is our sun, and 1/1,000,000th of a grain of sand is our beautiful blue planet Earth. When it first began to form, our Earth was very hot. Our Earth was very hot. There were many elements within our Earth. We had solids, gases, and liquids. And the rules that these elements had to abide by was that when you were hot, you would expand, and when you are cold, you would contract. So when the elements became really hot, they would expand and they would rush to the end of the Earth, where it would meet with the very cold universe. And they would take a bucket of ice from the universe and they would rush back into the center of the Earth and cool down the Earth with that bucket of ice, where they'd get hot again and then they'd be back to the edge of the Earth. And that we call the cosmic dance. And that carried on for probably billions of years until the Earth's cooled enough. I have 3 liquids here. I have water, I have oil, and I have honey. I want to show how these 3 liquids would interact with each other. So first I will pour some water. So there we have 3 distinct layers of the honey, the water, and the oil. And these 3 substances, they abide by this law that if you are heavy, you will sink down to the bottom, and if you are light, you will stay at the top. And even if I shake this, by the end of the day, they will all resume their place. As I mentioned, the heavier particles that were very hot, went to the center of the earth, and that created our core. The lighter particles became our mantle, as well as the crust, which, as you know, that is what we live on. And the even lighter particles became our atmosphere, the actual air that we breathe. While the planet Earth was still quite hot, after our crust had formed, there was still a lot of heat. And this heat did not have any way to escape. So it pushed and it pushed and it pushed. And it formed these beautiful volcanoes that Shona just told us about. And it exploded. And out came the heat. So here's my little volcano. While the volcanoes erupted and let out all its ash and gases, it covered the earth for many millions of years. While the earth was covered with this cloud, it began to rain. Once the clouds moved away, we got presented with our beautiful blue earth, and the sun could smile down on its daughter, the earth. And I would like to finish off and leave you with this thought. The world spins around itself and it dances around the sun. Although all elements are separate and unique, they are connected to each other. They are connected to us, for we are made of stardust, from that first great cloud of heat and light. The cosmos is within us all. We look at the sky with gratitude and we whisper, thank you.
Woo! Good job.